Today on the Woken Way, we are doing P9, interval notation and inequalities. So let's go ahead and get started. P9, interval notation. If you're in my class, you did an activity yesterday that led you into this right here. So normally I would just cross this off because we've already done it, but just in case, we're reminding ourselves that an open interval means that the two endpoints are not included in the solution, and when you graph, you use parentheses. A closed interval is when the solution is included. Your two endpoints in this case are included. It's much like open circles when you were graphing before, which we're not using anymore, and closed circles, our elementary school way of graphing inequalities, or maybe middle school. So the endpoints are included, but it can be half and half, so just be aware of that. We also have, if you have something like x is greater than a, and in this situation, you can have greater than or equal to, which would change it to a closed bracket, but we're just reminding ourselves that that situation would look like that. X is greater than a. Let me go back up here and just make these look like solutions. Here and here. Just a little shading to make it obvious. And then if it's less than, it goes the other way. So it's kind of cool because less than, this goes to the left. It kind of points like an arrow. This only works if your x or your variable is first, so don't get used to that. Like, actually think about what you're doing. The solutions that are less than or equal to some value, but because we're equal to this value, it would be a bracket instead of a parentheses. Okay, so the first thing we're going to do is tie this back to our Algebra 2 or Math 3H method of doing this, which was to use set builder notation. So you guys use set builder notation. What I would say is this says to graph first. So what I want you to do is, it doesn't say to graph first, but I want you to graph first. So this is saying include -2, -2, -1, 0, 1, 2, 3, 4, 5. I'm a little off. And then you would go until 5. So this is what it looks like. So in set builder notation, what this would look like is x such that x is going to be in the middle in this case because we have two values, and it's going to be less than or equal to -2 and just less than 5. So it's all the values that where x is, sorry, I said less than, x is greater than or equal to -2 and less than 5. So it looks like that right there. X such that it's within these constraints. So this one right here, if I didn't want to graph, it's in between 1 and 3.5. So I'd say x such that x is greater than or equal to 1 and less than or equal to 3.5. So when I graph that one, we go 1, 2, 3, 4, 1 and 4. Here is where 3.5 would be, and I would just make sure to have these be brackets because it's inclusive. Then we get to one that kind of looks tricky but isn't really. So this one is saying your solution set is all the numbers from -infinity all the way to +1, but don't include +1. So -infinity is way over here. So really what this is saying in set builder notation, another way to write this is x is less than 1. Okay? So moving on, we're just going to now work backwards and go from set builder notation to interval notation. We use interval notation, like I told you guys in previous videos, mathematicians are lazy. Set builder notation is a shorthand notation, but it's not as easy and as efficient as set builder notation or as interval notation. So in the beginning, you're not quite comfortable with interval notation, but in a couple of days, it'll be so much faster for you once you get the hang of it. So for this one right here, we are going to say x such that x is greater than or equal to 4. So what would that look like if we graphed it? Sometimes it's easier for us if we graph it first. So the cool thing about interval notation is it's always written from least to greatest. So start at your smallest solution, which is 4, and it includes 4. And what's the biggest solution? Well, this goes without bound, so it's increasing without bound. So it's going to positive infinity. Positive and negative infinity are always parentheses because infinity is not a number, it's a concept, so it can't ever reach infinity. So therefore, it's a parenthesis. Next one, x is less than negative 3. So here's negative 3. It can't include negative 3 in the solution set, which means it gets really, really close, like negative 2.99999999999. But once you hit negative 3, it's no longer part of the solution. So that's why we go to negative 3, because it can get infinitesimally close, but it just can't turn to negative 3. And so here's where kids get confused, because you see a negative 3. But remember, interval notation is least to greatest, and in math, least is on the left. So what's this number that it's going towards? What's the smallest number it can be? Well, it's going to try and reach negative infinity, and then it comes up to 3. These ones are a little easier with interval notation because you don't have to worry about infinity and negative infinity. This is going from negative 2 to 1. You can fill in numbers. And it includes negative 2. See, x is greater than or equal negative 2, or negative 2 is smaller than x. So that's going this way. And then x is less than 1, which is a parenthesis, and it's going this way. So it's where they're overlapping. So that right there is the graph of it, and then it's just negative 2 to 1. Part D is your or statement. So this one is considered an and statement because they're going together. So this is an and, meaning I could have written this like this: x is greater than or equal to negative 2 and x is less than 1. Again, lazy mathematicians don't want to write that every single time, so they found a way to write it together. You can only write it together for ands, and they're always less thans. You'll never see something that's like this. Mathematicians won't ever have greater thans in a combined statement in a shorthand notation, so just be aware of that. What this is right here is an or. So when you look at it, you have negative 3, x is less than negative 3, doesn't include negative 3, or x is greater than 5. What do you notice? They're not joining together. They're not overlapping. They're going away from each other. They're going away from each other like oars on a boat go away from each other outside the boat. So that's the or, helpful to remember. So how do you write that in interval notation? Just be very careful because it's actually one interval and then a break and then another interval. So the solution is actually 2 intervals from negative infinity to negative 3. And the symbol for or is a U. It stands for union. And then it picks back up at 5 and goes to infinity. So because there's a break in the interval, you have to write it as 2 separate intervals. Okay, so that's just the basics of interval notation. The rest of P9 is inequalities and combining it with interval notation. So this one says write in set builder and interval notation. I don't know if we need to do all of them in set builder and interval notation. So instead, I'm just going to have you do the first 2 in both, and then you can do the last 3 in interval notation instead of doing it in both. Okay? So right here, solve and express the solution. So we're going to be using interval notation throughout our class. There are certain situations where you have to use set builder, but not very many. So let's start solving this inequality. I subtract 2 from both sides like it's an equation, and I get negative 3x equals 3. And then right here, whenever you're dividing by a negative and you have an inequality, you need to flip the sign. So this ends up being x is greater than or equal to negative 1. So if it's set builder notation, we have x such that x is greater than or equal to -1. And in interval notation, we have -1 to infinity. And if you're like, how did you get that interval notation so fast? What I encourage you to do is just real quick graph, -1 greater than or equal to, and then you can see least to greatest. Okay? Next one, because we have x's on both sides, we're going to get 1x on this side. I always like to put my x on the left. You don't have to, but it makes everything easier. And then that's going to be greater than 9, because when I add 4 to both sides, then I'm going to divide by another negative. And I get x is less than -3. So set builder notation x such that, I should really have braces on these guys up here. That was silly. X such that x is less than -3. And this one would be from, just getting crazy with my brackets. The smallest number is actually -infinity, and the biggest number it can get really close to but not equal is -3. So again, just draw the graph if you need it. On the next one, this is an and statement, so I'm going to show you guys how to do it without splitting it up, but I just want to remind you, whenever you see those less than symbols, and you can see I wrote less than and to remind you, what this really is a simplified version of is saying 2x plus 3 is greater than or equal to 1, and 2x plus 3 is less than 11. And then you can solve both of those individually, or you can solve them at the same time. You just have to make sure you follow the proper procedures for solving. So we undo the subtraction or addition first. So I get -2 is less than or equal to 2x, which is less than 8. And then I divide everything by 2. So it's not what you do to one side, you do to the other, because there's actually 3 pieces here. So you just got to make sure that what you do to one piece, you do to all pieces. And because these are less thans, I'm good. If they were greater thans, I would want to make sure that I put them in order from least to greatest. -1 is smaller than 4, so we're good. And then, so my set builder notation is exactly what I solved. And my interval notation is going to be least to greatest, -1 to 4. Now we get into the inequalities with absolute values. So what I want to remind you on these, first, isolate the absolute value, always. So in this problem, the absolute value is isolated. If there was a number being multiplied in front, do not multiply that in. Distributive property is not, does not work with absolute value symbols. Or if there was like a -4, you would add that to both sides to cancel it out. So you take care of that first, and then you want to make sure that your absolute value is to the left. Like I said, it just makes life easier. So this is to the left. Once I have it on the left, I can say less than. That's an and statement. So it should be looking something like this. So what happens is I get x minus 2 is less than 5. And because of absolute value, which we saw in yesterday's lesson, it also means that negative quantity x minus 2 is less than 5. So when I divide by -1, that's going to give me what you guys are used to seeing, which is greater than -5. So you copy as is, and then the other one you flip and change the sign. That's why we flip and change the sign right there, because we end up dividing by a negative. If you don't do this first step because you're so used to doing that, you're fine. I'm not going to mark you wrong. So then we get x is less than 7, and x is greater than -3. So because it's an and problem, I take my smallest value, and x is bigger than that, and even when I write it like this, it is bigger than that, and it's less than 7. So that's how I write it as a compound inequality. So I just need to write in interval notation for this one. Oops, that's all I needed to do for that one too, forgot. So just -3 to 7. It looks like a point. How are you going to know the difference between when it's a point and when it's a solution? it's all context. You're solving an equation, so it wouldn't make sense for this to be xy because there's no y in the problem. Last problem on this set, the first thing I'm going to do is get my absolute value to the left side. So I am going to rewrite these. You kind of have to be careful that your absolute value signs don't look like ones. The absolute value, according to this symbol, is the bigger. So whenever I move sides, I need to change that sign to keep that consistent. Now this is not a less than with the absolute value on the left side. It's a great or, like oars on a boat. So we're expecting this inequality to end up away from itself. So 6 minus 3x is greater than 18, or negative 6 minus 3x is less than, or sorry, also greater than 18. Again, this is the step most students skip, but I use the definition of absolute value because I just always want that tucked in your head that it's what's in the absolute value that can switch from positive to negative, not this number over here. So then this is negative 3x is greater than 12, or I'm going to divide out that negative. I have that right there. So this would be x is less than negative 4 because I'm going to be dividing by that negative 3. And then when I keep doing the math on this one, I get x is greater than 8. So my statement, x is less than negative 4, or x is greater than 8. Because it's an or problem, I can't combine it into this, but I can use interval notation. So just as a friendly reminder, this right here says x is less than negative 4, or x is greater than 8. So not the best spacing on that right there. But what that lets me know is that I have two intervals. So negative infinity to negative 4, or 8 to infinity. And that's interval notations and inequalities for you. Have a good day.